This is June 2008 AS1. Question 4. Distinguish between gravitational potential energy and kinetic energy. I'll just scan in a wee bit there, it's a wee bit hard to see. Or maybe I won't. Anyway, so gravitational potential energy is energy that an object has because of its height. Or position above the Earth's surface. Just swap the pen. Above Earth's surface. Whereas kinetic energy, energy it has because it's moving. Has because it is moving. A car is parked on a slope. Normally the handbrake of the car provides a resistive force to prevent motion of the car. The handbrake in this car is defective and the car moves slowly but steadily at a uniform speed down the slope. Describe how the principle of conservation of energy applies to the car as it moves down the slope. Now, we know that you have gravitational potential energy at the top, and what should happen is that the car should accelerate down the slope, and all of that gravitational potential energy should be changed to kinetic. So at the top of the slope you should have a certain amount of gravitational potential, and at the bottom you should have the same amount of kinetic. But what we're being told here is that there's air resistance or friction happening. So the car has gravitational potential at the top, and that does decrease as it moves down the slope, and you get a mark for saying that. Because it's moving at a constant speed, then you're going to say kinetic energy down the slope is constant. Now, if that's the case, there has to be energy appearing to be lost there. And of course, energy is lost due to the work done by friction against the motion. And this is using energy, of course, and for energy is used. So that energy that's lost is used to overcome friction forces. And therefore, total energy is constant. And that's explaining the conservation of energy. And I'm just going to write down why. So the total GP at the top is equal to the kinetic energy plus the work done I've written overcoming friction, work done overcoming friction, or work done by frictional forces. It's fine. So that's your total. Your energy has been conserved. You don't need to write as much as that, but what they're looking for there is that the gravitational potential energy at the top decreases, the kinetic energy down the slope is constant, and then that there's work done used to overcome the force, the frictional force. This is part C. A passenger car at the top of a hill on the track of a roller coaster is travelling at a constant speed of 3 meters per second. It descends a hill and runs to the top of the second hill. Assuming that friction is negligible, calculate the speed of the car at the top of the second hill. Now, because it's got a constant speed, a speed at the top of this hill, we have to take account of its kinetic energy and its gravitational potential energy at the top of this hill. And so we're going to say that's equal to its potential energy plus its kinetic energy at the top of the second hill. So it has dropped a distance height-wise of 11 meters, but it's still got a gravitational potential energy of whatever the height of 14 meters worth is. And so we've written down here kinetic energy plus gravitational potential energy is equal to kinetic energy plus potential energy. So that's at the top of the first hill, the top of the second hill. So we're saying that a half mv squared plus mgh is equal to half mv squared plus mgh. Now the m's all cancel each other out. They're right across there. And so we're saying that a half times 3 squared plus 9.81 multiplied by 25 to start off with. And that's equal to a half. We don't know the v squared on this side of the hill, but we do know that we've got 9.81 times 14 on the other side. And therefore, this side of the equation gives us in total 249.8. That's equal to half v squared plus 137.34. And so v comes out to be 14.96, or rounded up to 3 significant figures, 15.0. So it's 15.0 meters per second, or meters seconds to minus 1. Explain in terms of energy where the answer you have obtained for the speed of the car is larger than would occur in practice. And there's 1 mark. So, because of air resistance and friction, work done by friction accounts for loss of GPE. There would actually be less kinetic energy at the end. So the car would have a smaller speed.